Hello, my name is Nolan Bach, and today I'm going to be showing a pathfinder between the moons of Kerbin. So here we are, or any planet really. So here we are on Kerbin. It has two orbiting bodies, the Mun and Minmus. The goal of this algorithm is to find a path that can be done within, or a route that can be done within the amount of delta V left in the ship, and gets to both the Mun and Minmus exactly once. All right, so I'll start this and then kind of talk through what's happening. All right, so a lot happened there, but the biggest thing is that what happens at the beginning is the entire route is planned. So the heuristic I'm using is that if you can do a Hohmann transfer or a direct burn at some place faster than you can do the same burn at the other, then you want to go to that one first. So in this case, it's faster to get to the moon than to Minmus. So like using Dijkstra-like logic, we're going to go to the Mun first and then decide from there where to go. The other thing that happened is I placed a bunch of nodes. So the reason that happened is because you can use some of the in-game mechanics about maneuver nodes to actually like place a ton of nodes and check how quickly you'll get to something. So that's how I do the ETA estimations. I place a node, check the ETA, store it, and then take the node off. So this all happened in like the first second, by the way, where it just like kind of the screen blows up. Um, and now I've decided to go first to the Mon, then to Minmus. Um, so that's my plan. It's the plan orbiting visit 0 body Mon, visit 1 body Minmus. Um, yeah, so like I was saying, you use this Dijkstra algorithm where like the moons are the nodes and the edges are burns to the nodes that fit within the existing delta V. But I also have an optimization where if I were to go to the Mon, have an encounter, not do a capture burn and come back, then I would kind of like float out here at a really high orbit and take a ton of time um, to actually get to a point where I can then do a burn to Minmus, because maybe I'll have to wait for a faraway point in my orbit, and if my orbit's total period is like 4 days, then that would be really bad. So instead, what I do is right now I'm still just getting in position to make a transfer to the Mun. But instead, what I do instead is I make a burn to the planet like the Mun, or sorry, a moon. I do a capture burn there, and then do an escape burn back into Kerbin orbit and lower my Kerbin orbit. And the reason that is because if, say, I'm on this orbit, I have to get a burn to Minmus, which is there. Well, maybe I know like it'll be there soon, so maybe I want to do my burn from here or from here. But waiting for one of those points could be a couple days on a really large orbit. And when I'm in low orbit like this, like my periapsis is 32 minutes away, and that is already behind me. So I have to make more than a full rotation to get to the or a little less than a full rotation, sorry, to get to the periapsis. So the entire period's like 33 minutes or something, which just means that I can easily wait if I want to do a burn right here. It's not like I have to wait a long time to do that burn. Um, so that's basically the plan. Is I'm going to get set up to do burns, go to that planet, get captured there, do an escape back on to the Kerbin orbit, lower the orbit, circularize, and then do the same thing to the next one. Um, yeah, and like I said, from testing, it was pretty significantly faster than just letting the orbit go past the Mun, circularizing out there, and going to the next one. Or and also more it's also more realistic because I can't burn all the way to the Mun, slow down enough, and then burn all the way back to Minmus, because that takes too much fuel to burn all the way up and then slow down and burn all the way back. So I think that's all the introductory stuff. One thing I should mention is that because it wasn't part of this challenge to get into orbit, I just started in orbit and I got up here with the unlimited fuel cheat on. And that's just to kind of like simplify things so that I can show that, so I could have more calculations that included delta V, but it also works, I think, on just even one rocket if it needs to. I know it does. Anyways, the other thing is that because this rocket is big and hasn't staged its lower parts, it turns slowly. And before you've locked on a maneuver node, it's a bad idea to warp. So I have to wait, unfortunately, for my ship to get aligned before all these things. All right, so what is happening now? I'm waiting for this maneuver node in 5 seconds. Oop, forgot that's where the... I'm gonna make this a little smaller. Okay, so now we're going to the mun. I think this maneuver is to circularize, maybe? No, that was the inclination burn. So I set my inclination at the mun. Okay, now I'm going over there. So I have 6 minutes till my, whatchamacallit, my 6 minutes to my maneuver, and then I'm going to go to my mun encounter. Yeah, so now I'm just, like I said, the turning is really slow on this ship because it's so big, and because I have lag, so I have to wait until it gets all the way down there. But once it gets there, I can jump all the way there. So it hasn't actually been 5 days because I let it be in orbit, and this is a game that I had saved for like my mun landing and stuff like that, so more things have happened. I think it started at 5 days or so, but obviously you can check that when the video ends. All right, so again, sorry, I have to get just down there. If you're watching this on YouTube, skip a minute. I'll just have slowly glided. Oh, and this telemetry is just describing some of the changes I have to make to the orbit to get it on an orbit that can encounter the mun. And oh wow, I'm getting really close. Yeah, wow. And then it tells me stuff about the node. Anyway, so once we're at the mun, once we're at the mun encounter, we'll see my first adjustment to actually speed up the process instead of just gliding from one to the other. Because it's so hard to calculate orbit to orbit burns unless you go straight at it, or like, yeah, unless you go straight at it and then slow all the way down, which takes up too much DV. I relied on Hohmann transfers that are slightly optimized Hohmann transfers where I place a lot of them. I do the calculations for a lot of them, and then I'll try to wait if, yeah, I'll wait if I need to for a faster one. But even with it, that's kind of like I calculate the lowest DV Hohmann transfer, and then I try places around it because I know that those are going to be the most likely for valid burns. And I try I think by an increment of 0.01, I change it 1,000 times. So that means 10 meters per second either way. And that actually is pretty significant because when you're only burning 800 meters per second to expand your periapsis to about like a factor of 10, if you switch, but even by like 1, you might just fly out of the orbit and be on a total escape. Anyway, so it looks like I'll be on my mun escape if I don't do anything soon, and then Kerbin escape, so I'd be into the sun. So obviously I have to do something way before that. And what I'm going to do, like I said, is capture burn, and then expand that orbit into close to Kerbin, and then get back on a slow one. Okay, so we got our first time warp, and then, like I said, I was just waiting for the maneuver. Well, I wasn't waiting. The program was waiting for the maneuver node to be lined up. And then we'll start this burn, it looks like, about 18 seconds, so I can help us get there a little bit. Yep, there it goes. Don't know if I'm allowed to close the terminal, but I guess I'm not. So here we go on our burn. Sorry for the lag again. You can see the abscess expanding. And then I think because, like I said, it takes so much unless I burn straight at the mun and then slow down as I pass it. takes so much DV there that I believe at this point will be just my biggest glide is from as I exit orbit and then glide into the encounter, and then I'll start burning. So here you can see some of my liquid fuel dropping off. It's auto-staged. Oh, you may not be able to see my mouse, but I'm pointing at the liquid fuel stages, obviously. All right, now I've expanded my apoapsis into an encounter with the Mun. Pretty solid burn. Yep. So the burn's over, and now I got a day, so I'm just gonna speed all the way up. Shouldn't block the time. I'm sure it's necessary for whoever's watching. I don't know if I mentioned, the path is optimized to minimize in-game time. It's not literally optimal, but that's the effort, is to make it optimal, because space is infinite directions and you can so little matter. Friction, no friction, makes it a lot harder to target to figure out what the exactly optimal burn is. But I try my best. All right, so one problem this is going to encounter that I just noticed is that the Mun periapsis is really low. So I think when I do my capture burn, I will slow down into the Mun, but this is a function I wrote for a Mun landing script that actually expands the periapsis if it's too low, so that should be okay. But just to explain what's going to happen first is this is going to, there we go. So here's my encounter. Now I'm in the Muns, and this is going to burn prograde for a second because it needs to expand the periapsis, like I said. Yeah, so it expanded to 50,000, and now it's going to make a slow turn to get retrograde so it can slow down once it's at the periapsis to bring in the apoapsis. And again, the reason for this is because if I'm in low orbits, they're faster and I can make transfer burns. Like I don't have to wait as long to make it transfer burn if it's over here, if I know I have a low orbit, because what matters is the angle, or part of what matters is the angle. The relative angle between the bodies that you're moving between. The orbits, I'm sorry, not the bodies. Anyways, like I said, we're waiting for this to move all the way to retrograde, which is going to take a while. Give you a real life minute. So maybe go ahead and just skip this. I'll just be here texting and whatnot, checking Twitter. Oh, the Patriots are on, actually. I'll check if they're winning. I think they're playing the Chiefs, so probably not. So again, I'm just waiting till this transfers to be facing retrograde. So while this process is slow for us, it's actually not really like slowing game time at all, because even if it takes 2 minutes, the entire journey, no matter how fast you do it, is going to take at least over a day, probably like 3 or 4 or 5. So these kind of turns don't really matter. And I'm not actually slowing down at all. I'm just not warping, which is the real lifetime. So it should be here pretty soon. The burning retrograde part. This will really be the slowest part of the video, so apologies. Yeah, sadly my internet's being so slow right now that I, through all this time, couldn't even load the score to the Patriots game. Oh, just loaded. 26-10 Kansas City. Well, I think we saw that one coming. Anyways, now we're locked retrograde, which is nice. So I can go closer to periapsis. Oops. I'm gonna go a little closer. So here are some of my other moon missions that landed. But obviously we won't be landing again. We're just waiting until I can do a capture burn here. All right, so I'm going to fast forward a little bit to get closer to the periapsis. Still just waiting for the maneuver to be there, but it looks like it's almost on horizon. So here we go. So now we got the burn going. We're going to bring the apoapsis in so that we can make faster transfers. So we're going to try to bring the apoapsis in pretty far because that lower orbit burn, or sorry, lower orbits just in general mean that they're going faster. So this is only like a 39-minute from one end to the other. So I'm going to warp over to the apoapsis. And again, the next part of this plan is I'm going to escape back into Kerbin, lower orbit there, and then make my way, hop to the next moon. This is what would happen on any orbiting system. I'd go from the moon back into the thing I'm orbiting by circularizing an escape, which is lower cost and in terms of fuel and faster than lowering my orbit after the moon encounter. So anyways, here I go. Time to apoapsis up there at 3 minutes. So I'm going to get closer because I think this burn starts at a minute usually from the apoapsis. Yep, there we go. So the reason I do this is because I know the periapsis is where I did my encounter. So the apoapsis will be on the other side facing back into Kerbin or any planet. And I know that because that's the nature of Hohmann transfers. So now I'm just expanding this until I'm escape the Mun's orbit. And then I'll be in Kerbin orbit, and my next job will be to lower the orbit because now the periapsis to apoapsis is 2 days. And obviously I don't want to wait 2 days. I want to get all the way over there quickly. All right, so here my time warp finished. So now I'm trying to turn to lock retrograde, but I'm burning. The idea behind this is that when I'm retrograde burning, the periapsis will come in, which is about to happen. It's still turning, as you can see. But even as we pass this, it should start coming in. Yeah, here we go. So we're trying to bring the periapsis in again because lower orbits mean faster times around them, which mean that we can find a launch window faster. So yeah, that's what's happening here. Then we will be on our next burn. Sorry, there's no good place for the terminal. It's kind of always in the way. And the reason I'm burning so, I turned on RCS by clicking that somehow. The reason I'm burning so slowly here, like at 0.1, is because the changes in DV so massively change the periapsis that if I had it at full throttle, even when I cut it at a certain rate, like I think here for every orbiting body, it stops at the height of its atmosphere plus 30,000, maybe 40 or 50,000 actually, because I want to be far away from from planets that don't have atmospheres. But because it's so sensitive to that, even turning off takes so long compared to how it's changing the orbit or the periapsis height, that sometimes I was just overshooting it. I guess we're about to find out what this offset I had was, because obviously Kerbin is 70 kilometers. So however high up we are, we'll probably see how much higher I wanted all the orbits to be. Again, I guess just in the interest of maybe skipping this part, all I'm going to do here is slow all the way down until this is at some level, go to the periapsis, bring this all the way in, recircularize the orbit. I guess circularization is interesting to watch though, but probably got 2 real-life minutes and a few in-game minutes, or hours, I mean, to wait. Okay, so the periapsis, so it looks like I probably set the limit at 150 kilometers, so that's 75 above the atmosphere. So now I'm just going to go to the periapsis, try to bring the apoapsis in, so that when I circularize, I still have a relatively low orbit. And again, all this fuss is just to get my orbit lower, so that I can, if I need to make an orbit over on this angle, I don't have to wait all the way until there. I can just do it in here, which will be faster. And just something of note, so we've gone to the Mun and we're going to Minmus, and this is now the second day, almost exactly, I think. So the reason this is expanding is again the same thing, where I'm trying to I'm trying to set the steering, lock the steering to retrograde with this very slow turning vessel, which is a pain. All right, so the periapsis will stay about at 150-ish kilometers, maybe 175, as this comes in, because I'm burning retrograde. And this will try to stop at a nearly circular place, but then I'll also circularize with a node that calculates it more exactly, because these corrective burns that just burn until some kilometer are often wrong. They're not really as precise as you need them to be. So all right, halfway through. Off to Minmus now and visit 1. So as a synopsis, we started in circular orbit, set the inclination to the Mun, did a Hohmann burn, kind of did a little bit different one where we did a capture burn to get to a good spot where we were facing back towards Kerbin. When we knew that escaping would put us back into a lower Kerbin orbit, we did so. Now we're lowering that orbit even more and bringing the apoapsis in. Once we've done that, we'll circularize to a little above where the apoapsis is. That's just how circularization works, at least in the script I wrote for it. And then we will set the inclination to Minmus, which is on a very different one, wherever it may be. I don't know why I can't see Minmus right now. Oh, I was looking at Minmus. I thought that was the moon. Had a weird perspective there. But yeah, so the inclination is different than our orbit, which is right here, this little blue one. That one kind of, I think, is at 6 degrees. Anyways, now we have set our circularization node, so we'll be at 367 kilometers. And again, now it's just an hour between these, and up there it was 3 days. So we can already see some of the benefits of moving to lower orbits, so that I can place my node. Now I just gotta wait for the to get locked onto the maneuver node. All right, which has been done almost. Yeah, so my auto warp starts. Which is really nice. Let me just make this little. We don't really need to see the telemetry anymore. Now what's going to happen is, again, it's going to try to do this process where once it sets the inclination correctly, it will try to place a bunch of Hohmann and Hohmann-like burns to try to find the fastest one. And once it picks one that is going to get there in the lowest estimated time by the maneuver node orbit that Kerbin returns and KOS returns, it's going to wait for that burn, which will be necessarily less than about 45 minutes then, and then we will, in game time, I mean, and then we'll do our last jump to Minmus up there. All right, I'm gonna. It waits to set the inclination to the periapsis, so I'm just gonna warp over there to wait for that to be done because we don't want to just sit here. Actually, I think it waits like 20 seconds before the periapsis or something. So I'll just warp us. Yep, here we go. All right, great. So now it's set the inclination. We can see after we've done this burn, the ascending and descending nodes will be at 0 degrees, which is perfect and exactly what we wanted. And great. So once we get locked on the maneuver, like another real minute. So maybe again, just fast forward. We'll switch to that. Again, so this sucks. It's because it's only long in real game, or in real lifetime. But obviously in the game, it makes like virtually no difference on the 2-day journey so far, like this 1 minute. And also we're not changing the speed at all. It just sucks that we can't warp until I'm locked on the maneuver. But we're getting close. Should be done pretty soon here. Should check the Patriot score again. All right, perfect. Locked on. Computer started our warp. Then we're gonna execute this node. Pretty small burn, about 200 meters per second. Looks like it should start to be even on both sides at 2.5 seconds. Then we'll be off to Minmus. Yeah, looks like probably we'll do something. I guess if I had to guess, like around here. I don't really know. I don't know how slow or fast Minmus moves, but it seems like that would be how you catch it. We'll see though. So again, the strategy here is we're getting our nodes aligned, which have been successfully. Yeah, great. Oh, my guess was way off. Okay, so this happened pretty much instantaneously, but I can talk through it as we move to our maneuver node. So the strategy on this is now, because we're in a lower orbit, it's easier to just not even worry about how much time it will take to get to a specific spot. So like, since it's over there, we needed to basically shoot this way. We could have like completely stopped our orbit and gone that way, but it would have taken tons of fuel. So it's easier to just align ourselves exactly behind where we expect it to be at a certain time, and then move over there. And so once the most effective, this isn't necessarily the most effective home and burn, or burn like home and like burn, since the home and burn is the most effective one. What happens is it finds the home and burn and then moves it around a little bit, adjusting at each new point the some of the burn stings about like how where your velocity vector is pointed. And once it finds the one that's lowest along this like smallish arc, then it places that one, and that's the burn we end up doing. So we'll have an encounter in 8 days. But again, relative to the amount of time it takes Minmus to orbit, which at 46 million meters away, it's actually not like too bad of a deal. All right, so our part of this is almost over because I've now run encounters with both moons. Well, not yet, but I will pretty soon. I'll warp over here and actually show the encounter once it's done. But obviously, the Kerbal graph doesn't really lie. But yeah, then the program will pretty much be done, and it will just kind of float off into space, waiting for the next thing. Might just kill it before then, so we don't have to just watch it go into nothingness. I think the sun's pretty far away. Oops. Accidentally almost hit a target. Yeah, the sun, far. So there we go, expanding our apoapsis in the correct direction. And I think the moon was actually like, where is it now? Yeah, so we escaped from maybe somewhere over here, I think. So we really needed to do this. Yeah, there we go. There's our encounter coming up. I'll go over there. But yeah, now it's pretty much done besides waiting. So we started at 5 days, 3 hours. This is going to take us till 8 days, I guess. No, 8 more days. So what are we at, 16 or something? And then we'll have our Minmus encounter. Then because the program is just meant to have 2 encounters, there's nothing really else to do. At that point, I'll just cut the computer. Cut the onboard computer. There's Minmus flying in. There's the transition. This is our encounter. And now we're in Minmus orbit. I think actually what the computer is going to try to do is stabilize that orbit and go back to Kerbin. But because we're done with the encounter at 17 days, so it took 12 days, a little less actually, 11 days, and well, pretty much 12, to get from Kerbin to the moon, back to Kerbin, and then to Minmus, to both kind of try to balance how much time it took and also with the DV. So obviously we started with, I think, 9,000 meters per second or something like that, maybe 8,000, and now we're down pretty far. All right, well, that is it for me. Clear screen here. Thank you for watching.